Hi there! This is Teacher Geraldine and today we are going to discuss Isaac Newton's third law of motion.
After going through this video, you are expected to infer that when a body exerts a force on another, an equal amount of force is exerted back on it. And specifically, you will be able to state the third law of motion, to identify action-reaction force pairs, and to infer that when a body exerts a force on another, an equal amount of force is exerted back on it.
If you want to explore all about science, come and join. Let us all learn. The science is fun. Science is cool. Watch and learn. The science is fun.
You probably know that when you walk, or run, or jog like them, you are actually exerting force on the ground by stepping on it. But what you didn't realize, the ground is also exerting force by pushing you upward. Amazing, right? This fact is the consequence of Newton's third law of motion, the law of interaction, and this will be the focus of our discussion. And by the way, who is Isaac Newton and his laws of motion? Well, let's try to go back to our previous lesson. Isaac Newton was an English mathematician and physicist who discovered the laws of motion. The first law of motion is known as the law of inertia. It states that an object at rest remains at rest. An object in motion remains in motion unless acted upon by an external unbalanced force. Also, it states that different objects have different amounts of inertia, the tendency of an object to resist a change in position. And the inertia of an object depends on its mass. Thus, the heavier the object, the greater the force is needed to change its position or motion. Further, the change in an object's motion or velocity over a period of time is referred to as acceleration. Therefore, the greater the force applied to an object, the greater the acceleration. A net force is produced when two interacting objects produced an unbalanced force, and the direction of the object's acceleration follows the direction of the net force. This gives us the concept of the second law of motion, the law of acceleration, which states that acceleration is directly proportional to the force, but inversely proportional to the mass of the object. This can be expressed in this equation. Acceleration is equal to force over mass.
Have you seen or heard about bamboo cannons? A bamboo cannon is a type of a homemade firecracker which is popular during the New Year's Eve celebration in the Philippines. Many Filipinos use kerosene bamboo cannons as an alternative to firecrackers during Christmas and New Year's celebration. It was said that bamboo cannons were introduced to the Filipinos by Chinese traders as weapons even before the Spanish colonizers arrived on the shores of the Philippine archipelago. Your parents might have experienced using bamboo cannons during their younger years. Ask them about it. They will surely tell you that when bamboo cannon fires, it recoils. It means that when it releases gas forward, the bamboo moves backward. This concept is very important because this says a lot regarding Newton's third law of motion, which will be the focus of our discussion.
The third law of motion is known as the law of interaction. It states that for every action, there is an equal and opposite reaction. Take note, equal in size, opposite in direction. Thus, if object A exerts a force on object B, then object B must exert a force of equal magnitude and opposite direction back on object A. Moreover, forces always come in pairs. This pair is known as action-reaction force pair. Identifying and describing action-reaction force pair is just a matter of identifying the two interacting objects and making statements describing who is pushing on whom and in what direction. To understand it more, Patrolwoman Masumbol of GSCPO CMFC will demonstrate to us how the gun fires. Let's play it again, this time in a slow motion. Observe that when a bullet is fired from the gun exerts a force on the bullet in forward direction. This is what we call an action force. The bullet also exerts an equal force on the gun in backward direction. The backward movement of the gun is called the recoil of the gun, and the recoil of the gun is the reaction force. Interesting, right? Another illustration is the deflating of balloon. When the air goes out from balloon, it pushes the balloon in the opposite direction. Observe that the balloon moves forward as the air moves backward, an explicit example of the action-reaction forces, isn't it? Now let's identify the action-reaction force here. Take note, the action force here is the one who or which is pushing. In this case, it is the balloon which pushes the air out. How about the reaction force? The one that reacts to the push is the reaction force. In this case, it would be the air that pushes the balloon forward. Now let's try to identify the pair of action-reaction forces in the next illustration. What is the action force? How about the reaction force? I will give you 10 seconds to identify the pair of action-reaction forces. Very good! You got it! The action force is the dribbling of the ball where the ball is pushed downward. And the reaction force is the bouncing of the ball where the ball moves upward. Try another one. The wheel on the tricycle as it travels along the street. I will give you another 10 seconds to identify the pair of action-reaction forces. Good job! You're so smart! The action force is the wheel pushing the ground backward, while the reaction force is the ground pushing the wheel forward, making the tricycle move to the direction of the net force. How about this one? A man skating. What do you think would be the action and reaction force? I will give you another 10 seconds to identify the pair of action-reaction forces. Brilliant! You're really a smart kid. The action force here is the skater pushing the ground backward, while the action force is the ground pushing the skater to move forward. But why do the skater move if the magnitude is equal? This is actually the common misconception on the action-reaction forces. The idea of equal magnitude may seem to be confusing because it seems to imply that forces are balanced so the object will not move. Let it be cleared that this idea is incorrect. Even though the forces are equal in magnitude and opposite in direction, they do not cancel each other because action-reaction forces act on different objects. Action-reaction forces is only confined in an isolated system, and this system refers to the pair of action-reaction forces. You must understand that the concept of action-reaction forces lies within an isolated system, meaning the pair of forces is not affected by any pairs of force observed in a given situation. Notice that there are more than two systems or pair of action-reaction forces that can be identified in this illustration. But let us just consider isolating two systems here. Okay, let us try to identify at least two pairs of action-reaction forces or two systems in the given illustration. Have you seen it? As you can see, there are more than two systems or pairs of action-reaction forces that can be identified in the given illustration. But let us just consider these two systems. For system A, we have the gravity pulling the skater downward for our action force, and we also have the ground pushing the skater upward for our reaction force. And for system B, our action force here is the skater pushes the ground backward, while the reaction force is the ground pushes the skater to move forward. In learning to isolate system or pair of action-reaction forces, you will be able to understand that forces in a system do not cancel each other because they are not affected by the forces of the other system in a given situation. But why does the skater move? It is because a net force is acting on these systems. It may mean that system B has greater force than that of system A. Thus, the direction of the object will follow the direction of the net force.
Now that you have learned the concept of the law of interaction, I will challenge you to identify the action-reaction force pairs of the examples that I will be giving. How many pairs of action-reaction forces do you see? Can you identify them? I will give you 60 seconds to look for them. Enjoy! Let's try to identify the pairs of action-reaction forces from the given illustration. I will be encircling at least 3 systems here. And let's start with the 2 sacks of rice, which is the color blue and the color yellow. In this system, the action force is the force that is exerted by the yellow sack to the blue sack downwards. And the reaction force is the force that is exerted by the blue sack in upward direction to the yellow sack. The next system that I'm going to encircle is this portion. In this system, the action force is the gravity that pulls the carabao downwards, and the reaction force is the ground that pushes the carabao upward. The next system that I'm going to identify is this portion, in which the rope is pulling the cart forward. In this system, the action force is the rope pulling the cart, while the reaction force is the cart pulling the rope backwards.
Now, let's sum up what you have learned. I will be giving concepts regarding the action-reaction forces. Say action if the concept is correct and reaction if the concept is incorrect. Let's try. The correct answer is action. Now it's your turn. Good job! The correct answer is action. Good job! The correct answer is action. You got it! The correct answer is reaction. Way to go! The correct answer is reaction. You are so smart. You got it. The correct answer is action. This time, I will be asking you to help me explain to the little boy in the picture how to move the boat forward. What do you think will move the boat forward? I will be giving you a tip. Use the concept of action-reaction forces. Think, think, think. You're so smart! The boy needs to paddle backward so the water will push the boat forward. Now let's check what you have learned. I will be giving 5 questions regarding the concept of action-reaction forces. Choose the letter of the correct answer. I will give you 60 seconds per question. After 60 seconds, I will reveal the correct answer for you to check if you got the correct one. Good luck! I know you can do it. Enjoy!
Question number 1. The correct answer is letter C. The second object exerts an equal and opposite force on the first object. Did you get the correct answer? I know you do. Now try the next question. Question number 2. The correct answer is letter B. Exerts an equal force back on the rock. I know you get the correct answer. Try the next question. Question number 3. The correct answer is letter D. All of the above. I know you got it. Now try another one. question number 4, the correct answer is letter C. The magnitude of the reaction force is greater than the action force. I know you got the correct answer. Now challenge yourself more by answering the last question. For question number 5, the correct answer is letter A, on the pole and also on the hammer. Good job! You made it!
I am happy that you have learned the concept of the law of interaction. Can you state it once again? Very good! The law of interaction states that in every action, there is an equal but opposite reaction. Don't forget. Have fun learning. Bye-bye.
If you want to explore all about science, come and join. Let us all learn. The science is fun. Science is cool. Watch and learn.